So now let's have a look at how we make rainbows. So the way that rainbows are formed is when light strikes water droplets in the atmosphere. To work out how this works, we need to go back to our dispersion principle, which is where, remember, light of different wavelengths will bend different amounts when traveling through a material. So kind of like our prism, where you would make the rainbow when you send light through, this is just happening with a roughly spherical water droplet. So what happens is sunlight, which has visible light of all wavelengths, will strike a water droplet. The light will both reflect and refract in the water droplet. Remember our dispersion principle that red light doesn't bend as much as what violet light does. So when the light actually strikes the surface of the water droplet, the red light doesn't bend very much, whereas the violet part of the light will bend a lot more. And then the light will reflect off the back of the water droplet. Because the red light didn't bend as much, whereas the violet light bent more, that means that they actually swap positions as they exit the water droplet back out the front. Now the rays leave the water droplet at various angles. So what we can actually do is work out what the angle is between the original sunlight rays and the most intense part of the rays that leave the front of the water droplet. The angle of the white sunlight that enters the water droplet and the most intense red part of the light that leaves the water droplet is 42 degrees. This same angle for violet light is only 40 degrees. So you can see for rainbows, what's happening is the sunlight, for you to see a rainbow in front of you, the sunlight has to be behind you and the light comes in, reflects off the water droplets and comes back down at you at between this 40 and 42 degree angle. And so now let's look at a whole rainbow and how these angles factor in to what we see in the sky. So here, what we have is exactly what I just said before. We have the sun coming in at roughly parallel rays towards water droplets in the atmosphere. Keeping in mind that the brightest of the red is seen at an angle of 42 degrees and the brightest of the violet is seen at an angle of 40 degrees. Now this is why the red appears at the top of a rainbow and the violet appears at the bottom of a rainbow. Remember, the angle is smaller for violet, therefore the brightest part of violet is lower than the brightest part of the red, and the difference between them is roughly 2 degrees. So to locate a rainbow, remember the sun has to be behind you and you need to have what we call the anti-solar point in front of you. So to locate a rainbow, what you would do is you would point your arms in the direction of your shadow, whether that be higher or lower in the sky. You point your arms to where your shadow is. And then you would move your other arm until you were at an angle of 42 degrees between your arms. And if there are illuminated droplets in that direction, you will see a rainbow. Now, a rainbow only needs to be 42 degrees in any direction away from the point that is exactly opposite the sun. So that's why we end up with a 42-degree circular arc around the anti-solar point. Now the top of a rainbow, in this case, is never more than 42 degrees above the horizon. When the sun is above the horizon, the anti-solar point is below the horizon, so only a lower arc, a shorter rainbow exists. And this is all because a droplet in any 42-degree angle direction from the anti-solar point will create a rainbow. It just needs to be exactly opposite where the sun is. But you may have seen not just primary rainbows, but also secondary rainbows. Secondary rainbows, I don't know if you've noticed, but the color is actually reversed. And this is because instead of just having a single reflection off the back of a water droplet, we actually get two reflections off the back of the water droplet, as shown in the image. Higher order rainbows are also possible, but their intensity is very, very low. For secondary rainbows, the angle where the most intense light occurs for between red and violet is roughly 52 degrees. And that is how we make rainbows.